So good morning to everyone. Let us start. Where we are right now. So we have already finished 2.1, 2.2, and we also finished 2.3. So now there is one more topic that is related to pigeonhole principle, which I will eliminate, not now. Now I am going to start with a little bit about partial order relation and poset, and if time permit, Hasse diagram, and then I will omit this part for time being. Then I will straight away going to start with the first unit for your today's session. So let us quickly try to understand what is partial order relation. So we already seen what is equivalence relation. Equivalence relation is a relation that is reflexive, symmetric, and transitive when it satisfies these three properties. Similarly, what is partial order relation? When we say a relation is partial order relation, when it is reflexive, antisymmetric, and transitive. So where is the difference? It is with respect to symmetric and antisymmetric nature. So please try to understand what is symmetric relation and what is antisymmetric relation that we already studied. In symmetric relation, if you have A related to B, then B related to A is also there in your symmetric relation. In antisymmetric relation, if A is related to B and B related to A, then both A and B has to be same. That means you cannot have A related to B and B related to A, where A and B, they are not equal. Then such relation is not antisymmetric. So either the elements are related or they are not related. That's it. So this is your partial order relation. So we already seen now antisymmetric means if A comma B belongs to R, then B comma A do not belongs to R unless B is equal to A. So thus A comma A is allowed in R. That's why it is reflexive. But since it's reflexive, all possible A comma A must be in R. So what is partial order set? So we have just now discussed what is partial order relation. A relation which satisfies reflexive, antisymmetric, and transitive property is called as partial order relation. What is partial or partially ordered set? That is called as poset. A relation R on set S is called a partial ordering or partial order if it is reflexive, antisymmetric, and transitive. A set S together with partial ordering relation R is called as poset. So technically we denote something like this S comma R, where S is a poset. Poset means what? On this S there is S to S there is a partial order relation R. So we call S comma R as a poset. Let us take some example. So assume you are having one set that is 1, 2, 3, and let us say this is given relation R, which is 1, 1, 2, 2, 3, 3, 1, 2, 3, 1, 3, 2. So it is reflexive. Why? Because every element A belongs to S. A comma A is there in R. So you can see here 1, 1, 2, 2, 3, 3. They are there in R. Similarly, it is antisymmetric. Why? Because 1, 2 belongs to R, 2, 1 do not belongs to R. 3, 1 belongs to R, 1, 3 do not belongs to R, 3, 2 belongs to R, 2, 2 do not belongs to R. It is transitive. Why? So you can see 3, 2 belongs to R, 2, 2 belongs to R, so 3, 2 also belongs to R, 1, 2 belongs to R, 2, 2 belongs to R. So you can see 1, R. Now here 2, 2 and 1, 2, 1, 2, 2, 2, that is 1, 2 in terms of transitivity. So it satisfies transitivity also. So there is no issue. It is a partial order relation. So how we denote partial order relation? So in a poset, the notation A, you can term this as partial order relation. It is something like less than or equal to symbol. So A partial order relation B means what? A is related to B but partially, partial order relation. So we denote this by a special symbol. This symbol indicates A is partially order relation with B. So note that the symbol is used to denote the relation in any poset, not just less than or equal to relation. The notation A related to B denotes that A is partially related to B, but A is not equal to B. Okay. So let's proceed ahead. Okay, what is the difference between these two symbols? This symbol and this symbol. So the notation is used because the less than or equal to relation is a paradigm for partially ordered. A is less than or equal to B. The notation A less than B denotes A is less than or equal to B, but A is not equal to B. So it is something like stricter partial order relation where there is no equality. Coming to this case example, 2 is partially ordered relation. 2 is less than or equal to 2, but 3 is less than or equal. This is not exactly your mathematical less than or equal to. That's why you can see there is some difference between the symbol. It is not less than or equal to. It is partially ordered relation. So 2 is partially ordered related with 2, whereas 2 is equal to 2. Therefore, it is this equalities you can see here. Wherein here 3 is partially ordered related to 2, but 3 is not equal to 2.
So
Are you
can you
again?
explain how 2 is partially ordered to?
Okay. For that, you need to understand what is the meaning of partial order relation. When we say a relation A is related to B, let me just see here. Yeah. In the POSIT, the notation A partially ordered related with B denotes A comma B belongs to R. When A comma B is belonging to partial order relation, between these two elements, we are having this partially ordered relation. What does it indicate? It indicates A is partially ordered related to P. Now, what does this equality mean? This equality means what? A is partially ordered related to B, where A and B both are same in terms of their antisymmetric definition. But if A and B they are not same, then we denote like this. The equality means what? Where this is in general we are writing. With, it is not with respect to any particular context. It is in general. For all A comma B belongs to R, A is partially ordered related with B, wherein this equality indicates A and B both are same. But if they are not same, it is denoted something like this. That's it. This indicates what? A is partially ordered related with B, but A is not equal to B. This indicates. Wherein here it is in general, A is partially ordered related with B. If it is not equal to B, then it is something like this. So coming back to here, this case, 2 is partially ordered related with 2. Why? Because this relation is itself partial order relation. This 2 comma 2 belongs to partial order relation, wherein 2 is partially ordered related with 2, and this equality is there because A is equal to B. It is for B and B, A has to be. So here A and B both are same. So A is related to A and B both. That's why this equality is. Coming towards here, 3 comma 2 to this partial order relation. So A is related to B, but B is not related to A. So therefore there is no such equality. Is it clear, Viraj? Hello, Viraj, is it clear?
Yes, sir.
Any difficulty still? Let me understand this. What is any
Yes,
ambiguity between
sir.
these two symbols? No. Okay. Let's proceed ahead. Okay. Let us take some example. Greater than or equal to is a relation on said Z. So we want to check whether it is a partial order relation or not. This greater than or equal to relation on Z to Z is partial order relation or not. What is Z? It is set of integer. So for all elements A belongs to Z, you can see A is greater than or equal to A. Yes, it satisfies reflexivity because A is greater than or equal to A. So definitely each element is greater than or equal to itself. So reflexive property is satisfied. Coming back to the antisymmetry, if A is greater than or equal to B, then the only way that B is greater than or equal to A is when B and A both are same. So it satisfies antisymmetric property as well. And transitivity, when A is greater than or equal to B, B is greater than or equal to C, obviously A is also greater than or equal to C, so transitivity is also satisfied. Therefore, This greater than or equal to relation from set Z to Z is a partial order relation. So how we denote poset? Z comma that partial order relation means what? Set comma partial order relation on that set. This Z comma this relation is termed as poset. Okay. So consider another example, power set of A comma B comma C, and suppose we do have a power set of A comma C and the subset relation on that. So power set of A comma B comma C is a set on which this subset relation is applied. So what I will do, there are many more things which I am skipping at present. We will discuss this once we finish our module number 1 because I need to cover syllabus from your IIT 1 perspective. So straight away I am going to start now. I just introduced quickly what is partial order relation and coset. Still there are few things remaining that need to be discussed, which I will start discussing the moment I finish this module number 1. So let me start now quickly module number 1 with propositional logic. Okay. Mm, So let us try to understand what is first of all logic. So logics are formal languages for formalizing reasoning, in particular for representing information so that conclusion can be drawn. So a logic involves a language with a syntax for specifying what is a legal expression in the language. So syntax defines well-formed sentences in the language, semantics for associating elements of the language with the elements of some subject matter. So semantics defines the meaning of the sentences. And there are certain inference rules for manipulating sentences in the language. So what is the directly I will start with propositional logic. So propositional logic okay. So propositional logic is a formal language for representing knowledge and making logical inference. What is proposition? Proposition means it is a statement that you already learned in your English grammar or Marathi grammar, whichever language you are studying. What is meaning of proposition? It is a statement, either that is true or it is false. It's a statement, means what today is Monday. So either this statement is true or this statement is false. Any statement is called as proposition. So remember this. Now what is meaning of compound proposition? More than one sentences combined together with some logical connectives like and or something like that. Today is Monday and there is rain. So today is Monday, this is one proposition, there is a raining, there is another proposition, and we are connecting these two propositions together with some connectives, logical connectives like and or. So it's like more than one proposition in a single, it's, you can say like composite proposition, that is called a compound proposition. What is the truth value? What is the truth value of a compound proposition? So when you do have two propositions or more than one propositions connected with some connectives, what is the conclusion about that whole compound proposition? For example, if I say today is morning and there is raining. So I want to know, see, today is morning and there is raining. This is a one complete compound statement. So whether this statement is true or false. So I need to understand today is morning Yeah, this is true. And there is a renning. There is no renning, so the entire statement is not true. Since there is an and proposition, and means what? Both conditions are fulfilling. So both are not fulfilling. Therefore, the truth value of this compound proposition is false. So the truth of a compound proposition is defined by the truth value of elementary proposition. What is meaning of elementary proposition? Every atomic proposition that is involved in that compound proposition, we need to identify the truth value, and on the basis of the logic connectives, we'll find out the aggregated truth value of the entire compound proposition. We'll see this shortly. The truth table for a compound proposition table with entire rows for all possible combination of truth values is truth table. So let's see quickly what is compound proposition. So there is one statement, 2 is prime. So let us denote this statement by some variable, propositional variable. We call this as a propositional variable. So normally we take propositional variable in small letter to denote that. And normally we denote the set using capital letter. That's the difference to understand between the propositional variables and the set label. So what is the point of discussion? That this is one of the proposition atomic statement which we denote using some propositional variable, that is p. The value of this variable is either true or false. Either true or false. Similarly, another statement, 6 is prime. It is denoted by some propositional variable, that is q. Its truth value is either true or false. So at present it is false. So now, what are the various operations that you can have? I will discuss here. So these are the possible connectives that you can have in your propositional logic. Propositional logic means it is the propositional statements that you are converting into propositional logic, and you need to evaluate that propositional statements using rules of inference. So what are the connectives? Connectives are nothing but the operation, just like in set theory we discussed what are the operations that we can perform on set, like you can have a absolute complement, relative complement. You may have binary operators like union of two sets, intersection of two sets, set difference, uh, relative difference, something like that. Okay. Similarly, here you do have operators on propositional variables. So out of that, this negation operator, or it is sometimes also called as not operator, is a an unary operator. Unary operator means what? It requires only one input argument. Okay, it do not require two input argument. It requires only one input argument. In this case, unary means what? Not operator is applied only on single propositional variable. That's why it is unary operator. The rest of the operators like and or single implication, double implication, these are applied on two propositional variables. So all these and or single implication, double implication are binary operator. Meaning of binary operator means it requires two operands, two propositional variables. Okay, so let us try to understand how it works. So let us quickly summarize what we discussed. Syntax of well-formed formula, that is WFF, or sentences. Atomic sentences are well-formed formula. Atomic sentence, like each propositions which we are not able to differentiate or decompose further atomically. Okay. So negation of W1 is what? Let us try to understand. Okay. The truth table we need. So let me just open the Excel file. So let us assume P is some statement. Okay, like today is Monday. P is a propositional variable. Okay, P is a propositional variable. Let us say Q is equal to there is holiday. Let us say. Okay, this is some another propositional variable. So what is the point of discussion? We are now discussing what is the value of P. Okay, can anybody tell me now what is the truth? Either I will just write here truth value of any propositional variable is either true or false. Okay, the truth value of any propositional variable is either true or false. That's why this is a binary logic. Propositional logic is a binary logic. You can have either, there are only two outputs, either it is true or false, either it is yes or no, either it is 0 or 1, something like that. So can you tell me what is the truth value of P at this time, for time being? What is the truth value of P? Yeah, someone quickly tell me what is the truth value of P?
True.
That is true, yes. What is the truth value of Q? False. Okay. So now we are discussing one by one each operator. Now the first operator is, that is negation, or it is also called as complement of complement operation. Okay, and it is denoted by symbol. I'm not going to here is the symbol. Okay, so now we want to know what are the possible. See, negation operator, negation array requires only one input argument. So let us say I want to identify not of P. Since I am not able to draw the symbol, I am just writing in words, not of P. Wait. Yeah. If this is your P, then what is your not of P? So if your P value, this is in general we are writing, not with respect to this statement. I'm talking now in general. If your P value is true, what will be the not of P? Hope you are able to view my screen.
False.
False. If it is false, if P value is false, what is not of P? If P value is false, what is not of P?
It's not Monday.
True.
True. Okay, very good. Are you able to see what I'm typing right now? I have drawn one table. Yes or no?
No,
Please
sir.
let me know.
No, sir.
Okay, okay. In between, Please give me feedback because there is some issue with laptop connection. So again, I need to reconnect. Wait for a moment. Now you are able to view.
Yes, sir.
Is it visible? Okay.
Yes.
So now this is only this is the only one operator which is a unary operator. Rest of the operators are binary operators. So one of the logical connectives that we are learning now, and so it is symbolically denoted by something like this. Okay. So this is a binary operator. Now, when I say binary operator, it requires two operand, two propositional variables. So let me the whatever we are right now drawing, it is a truth table in general. Let us say P is your one of the propositional variable, Q is your another propositional variable, and we want to know what is P and Q. Okay. So how many propositional variables are there now? Two. So what will be the possible combination of the truth value of two propositional variables? What will be the possible combination? Combination means what? If P is true, Q is true. This is one of the possible combination of truth value of P and Q. Likewise, how many possible combinations for two variables?
4.
4.
Four. So if P is true, Q is true. What is another? If P is true, what is another possibility for Q?
If
So false.
False. Q is a propositional variable. Every propositional variable is either true or false. So these two things we have done. Then suppose P is false,
So
Q
true.
is also false. Q is false, Q is also true. Something like that. So let me just make this as a table and let us quickly discuss the result. So now can you tell me now if one of the statement is true, other is true, what is the entire statement?
true,
If today is Monday is true, there is a holiday is also true, and when I say today is Monday and there is a holiday, what will be the resultant compound statement value? Truth value of this.
False.
I'm sure you are learning now digital logic in your this course. Same thing is there. Okay. So it is true. What about this?
So false.
Why false?
false.
Because let us not take blindly this false. We need to understand why false. If we want to know what is the truth value of this, when we say P and Q together, is it true or not? When it will be true, when every atomic propositional variables are true, then and then only this compound proposition is true. That's why we can see one of the propositional variable is not true, therefore this is also not true. So when we will declare this is false, if at least one of the proposition involved in this compound proposition is a false, straight away this compound proposition truth value is false. Similarly, same principle applied here, at least one of the propositional variable is false, compound proposition is false. Similarly here, which is false. So hope this is clear. Let us go ahead. Same thing. Another propositional logic connective is OR operation. So similarly here, we'll discuss now what is P or Q. And now what is meaning of this P or Q? This is a compound proposition. So when this will be true, then at least one of the propositional variable logic, sorry, one of the propositional variable is having truth value true, then we say that compound proposition is true. So it is a or, no? Either this or this. It is like you go to bank and they ask you to submit this following document. Either this document or this document or this document or this document. If out of this at least one document you furnish, then you are satisfying that eligibility criteria. At least one propositional variable is true, then your entire compound proposition is also true. So with this, you can see at least one true is there, so therefore this is true. At least one true is there, therefore this is true. At least one true is there, no, therefore there is false. At least one truth value true is there for proposition yes, so therefore it is true. That's it. So understanding these three operators, there is no much complications. Now the next one, wait. The next one is your single implication. That is, we do not something like this. P implies Q. Yes. This is also called as. Let's check that it is here. Wait a minute. Yeah. So AND operator is also called as conjunction. OR operator is also called as disjunction, and this is single implication where the W1 is called as antecedent, W2 is called as consequent. So let me just write this here in Excel. This is also called as conjunction. This is also called as disjunction. This is implication. So in this, P is antecedent, and Q is consequent. Okay? Let us try to understand this. So let me take some example. Let us say P is I will give you a gift. Now we don't know whether this is true or false. This is in general one propositional variable, and Q is you pass an examination. Okay. There are two statements I have written here. One is I will give you a gift. I will give you a gift. This I denote using propositional variable P. There is another statement. You passed an examination. This I have denoted by propositional variable Q. Now, there can be the single implication operator requires two operands, that is two propositional variables. So you may have two implies P also. We'll discuss this. Okay. Similarly here, you may have, since it is a binary operator, you should know what is Q and P also. I'm again writing this. So Q and P. So again, T and T is T. T and F at least, sorry, if there is at least one F, then it is entire statement is false. At least one F entire statement is false. At least one F entire statement is false. Similarly, Q or P. So here, if at least one propositional variable is true and one proposition is true, so I'm just working for Q or P. I'm just writing the result. So one true is there, therefore true. There is at least one true, therefore it is also true. There is at least one true, no, therefore it is false. There is at least one true, yes, therefore it is true. So why I have written this, it is just to understand whether, what is this? This is AND operation. It is satisfying commutative law. What is meaning of commutative law? P and Q is equal to Q and P. Therefore, this AND operation, conjunction operation, satisfies the property. Similarly, OR operator is also satisfies commutative law. That is, P or Q is always equal to Q or P. It satisfies commutative law. So there is no, we can commutative property for negation because it is an unary operator. It requires only one input argument. So for binary operators, we need to check commutative law. So now we'll go for the single implication. Now let us try to understand what is P implies Q. So we already noted okay. So we already noted what is P. I will give you a gift. And what is Q? You passed an examination. So what is the transformation of this propositional variable, compound proposition variable? P implies Q. P implies Q means what? What is P implies Q? That I will give you a gift if you passed an examination. Okay. And what is Q implies P? If you passed an examination, okay, how it is interpreted, no, that also I need to write here. It means if P, then Q. Okay, this is the interpretation of this P implies Q. So if Q then P means what? If you have passed an examination, I will give you a gift. No, P implies Q is not like this. What is P implies Q? If I will give you a gift. If I will give you a gift, then you have passed an examination. Let us try to understand what is this basically. Okay, what we need to identify, given what is the truth value of P, given what is the truth value of Q, we need to understand what is the truth value of this single implication P implies Q. So what is given to you? P implies Q. We need to identify. So right now it is given to you. I will give you a gift. I have given you a gift. This is true. Let us this is the current scenario. And you have also passed an examination. This is also true. So we need to check P implies Q. What is the truth value? At present, the facts are given to you that I have given you a gift. It is a truth. Means I have really given you a gift. And I have passed an examination. This is also true. So what is P implies Q? If I give you a gift, then you have passed an examination. So at present, please try to understand what is meaning of this. Irrespective of this example, when this single implication will fail, what is the interpretation of this? If P is true, then Q has to be true. If antecedent is true, then Q has to be true. It is something like this. If I have given you a promise that if you fulfill antecedent, then I will give you something. That promise is there. And you have fulfilled that condition, and I am not fulfilled the post promise, post event of that commitment. That is, if P is true, Q has to be true. If P is true, and now you are away from your commitment, that is truth value of the single implication is false. So I will just go with respect to this example. I have given you a gift. Okay. What is the promise that I have given to you? If you pass an examination, I will give you a gift. Okay. Now what is P implies Q? I have given you a gift. It's true. And what is this T indicates? You have passed an examination. This is also true. So it is a valid statement. P implies Q is a valid statement. That is, if I will give you a gift, then you have passed an examination. This is true. There is no violation of the single implication. When it will get violated, if P is true and Q is false, it is going to be violated. So we'll see this here now. What is the truth value of P? I have given you a gift. I will give you a gift. What is P implies Q? If I give you a gift, it indicates you have passed an examination. This is the interpretation. And the truth value of you have passed examination is false. What is the interpretation of this? If P is true, then Q is true. If P is true, then Q is true. But here, if P is true, Q is not true. Therefore, P implies Q is also false. Now, okay, please try to understand. It is something like in your programming instruction. If you are having this condition P, wait a minute. If some condition P you do have, then you may have something that is Q. That's it. So when Q will get executed, when P is true. That's it. This is what exactly we are discussing here now. P implies Q. So when Q will executed, when P is true, then only Q will get executed. Right? what is the interpretation of this? When P is true, Q has to be executed. This is in a layman's term, some analogy example I am giving. If P is true, you cannot say now, I will not execute Q. You have to, you are bound to execute that Q because P is true. Because P is true. Okay. Similarly here, if this condition, if I will give you a gift, then you have passed an examination. So I am giving you a gift, but you have not passed an examination. So P implies Q is false, because if P is true, Q has to be true. So this P implies Q is false. Now going ahead for the next combination. If P is false, that means if I will not give you a gift, then you have not passed an examination. So it is satisfying the P implies Q property. That means what? When P implies Q is waiting to be violated, if antecedent is true and Q you are not, and Q is that consequent is not true, then and then only this is going to be violated. Otherwise, no matter what is the truth value apart from truth, if it is false, no matter what is the truth value of Q, your statement is not violated for single implication. So if I am not giving you a gift, you have not passed examination, this is valid. If I am not giving you a gift and you have passed an examination, if I am giving you a gift and you have passed an examination, this is also true. Why? When this is going to be false, when I am giving you a gift, you have to pass an examination. If P is true, then Q has to be true. If I am not giving you a gift, it doesn't mean that I am violating my condition. If I am giving you a gift, then I need to check what is the Q part. But if I am not giving you a gift, I am not going to check this. This is with respect to P implies Q. Let us take Q implies P. What is Q implies P? If you have passed an examination, I will give you a gift. Now we will check this. You have passed an examination? Yes. I have given you a gift? Yes. So yes, Q implies P is true. You have passed an examination? No. Sorry. You have passed an examination? No. And I am giving you a gift? Yes. So there is no violation. What is Q implies P? If you have passed an examination, I will give you a gift. What is my promise? If you pass the examination, I will give you a gift. When my promise will get violated, you are passing an examination and I am not giving you a gift, only in that scenario the promise is violated. Otherwise, you have passed examination, I am giving you a gift. This is one possible combination. You have passed examination, I am giving you a gift. This is valid. I am not violating any condition. Next, you have passed examination and I am not giving you a gift now as per my promise, then I have violated. So therefore, promise is violated when you have passed examination and I am not giving you a gift. That time, the promise is violated. You have not passed an examination and I am not giving you a gift. Still, the promise is not violated. You have not passed an examination and I have given you a gift. Promise is not violated, because when the promise will get violated, you have passed an examination and I am not giving you a gift. That time only the promise is violated. You have not passed an examination and I am giving you a gift. Nowhere I am violating the promise. I can give you a gift as a compliment. When my promise will get violated, when you passed examination, I am not giving you a gift. Only that time the promise is violated. Else the promise is not violated. So doing that way only. If you have passed an examination, you have not passed examination, I am giving you a gift. No, my promise is not violated. Truth value is true. You have not passed an examination, I am not giving you a gift. No, my promise is not violated. You have passed examination and I am not giving you a gift. My promise is violated. So therefore, this is the truth value. So when your single implication is false. Yeah. Any question? Okay. When your single
If
implication is false, yeah, Gaurav,
it's the third one, like both are false in that case.
you are talking about P implies Q or Q implies P.
So Q implies P.
Yeah. Third one. Here, please try to understand. What is my promise to you? I will give you a gift, Gaurav, when you will pass the examination. This is my promise to you. Now, in reality, what is the situation? You have passed an examination and I am not giving you a gift. So you can say, sir, you promised that you will give a gift and now you are not giving gift to me because I have passed the examination. Now you are bound to give me the gift. Why? Because you promised me if you pass an examination, I will give you a gift. I have passed the examination and you are not giving the gift. So Q implies P means what? It is a promise. If you pass an examination, I will give you a gift. This promise is not satisfied here, so that this promise is failed. If you pass examination, I am not giving you a gift, this promise is failed. Now looking to this third situation, that what is this third situation now? My promise is what? If you pass an examination, I will give you a gift. This is the promise before the event. Now, event happened, and what is the truth value of the event? You have not passed examination, and I have not given you a gift. That is what Q implies. What is the truth value of Q now? You have not passed an examination implies what is the value of P now? I have not given you the gift. You have not passed examination. I have not given you a gift. I have not violated my promise. My promise will get violated when you are passing examination and I am not giving you a gift. You have not passed examination. I have not given you a gift. So therefore, the I have not violated my promise. Take another situation, that is true. You have not passed an examination. Still, I am giving you a gift. I can give you a gift. No, nowhere I have declared earlier that if you do not pass, I will not give. Sorry, nowhere I have
So,
declared this. Yeah, yeah, yeah.
no,
Gaurav,
so
tell me.
continue. So continue.
One is what you have not passed examination, and I am giving you a gift. What is my previous promise? If you pass an examination, I will give you a gift. That's the promise. Okay. Whether I am violating that promise here, you have not passed examination. Still, I am giving you a gift. Is it violating my promise? No. Because what is my promise? If you pass an examination, I will give a gift. When my promise get violated, you have passed examination and I am not giving you a gift, then and then only the promise is violated. Otherwise, you have passed examination, I am giving you a gift, promise is not violated. You have not passed examination, I am not giving you a gift, promise is not violated. You have not passed examination, I am giving you still gift, promise is not violated. That's why, what is the conclusion from this? When the promise, that promise is nothing but what Q implies P or whatever P implies Q. If the antecedent is true, that's a promise. If antecedent is true, and Q is not true, then and then only the symbol implication truth value is false. Otherwise, it is not false. Yeah, now you can ask me the question.
So clear.
Okay. What about the rest of the student? Please do reply on my chat box to understand whether this is clear or not. Because in line with this, there is a double implication. The moment you understand this, double implication will also clear in a short period. So please do reply immediately in the chat box to understand. Okay, so if there are no more questions, I will proceed ahead. You can see now we are talking now, we are checking now whether this is commutative or not. Is it commutative? You just tell me now by looking to this. Yeah, tell me, is it single implication is commutative or not? Yes or no?
No, sir.
No. Very good. Now let us proceed ahead for double implication. This is P if and only if Q. This is the way you should interpret. If P if and only if Q. P if and only if Q. How to interpret this? What is meaning of this? If P then Q and this is the meaning. No, this is double. Okay. So P if and only if Q. Similarly, Q if and only if P. Uh, since the lack of time, I will have a further discussion from this point onward in tomorrow's session. So you can post your attendance in the chat box.